This demo is focused on the data consumer side. Specifically, the following capabilities will be demonstrated. Specification of policies formalized inside an organization in order to regulate its operations against a variety of provisions. These may originate from applicable legislation like the GDPR or other operational and data governance considerations or by a marketplace. Data processing workflow DPW specification as the primary means through which the data consumer states their intentions for the data they seek to acquire. These intentions are derived from jointly considering a variety of aspects modeled within a DPW definition, including the processing operations intended to be performed, the entities in control of their execution, both directly and indirectly, the exact properties of the acquired data and the conditions under which any processing and exchange is meant to take place, and the stated purposes that the DPW in question is intended to serve. Finally, conflict identification and resolution at the level of the organization in the context of addressing discrepancies between any user-defined DPW and the organization's internal policies. At a second phase, this functionality will be further exploited in the context of negotiation towards resolving the conflict that may arise between a data consumer-defined DPW and the constraints imposed by the corresponding data provider S. These capabilities will be demonstrated via the ICT Abovo GoodFlows tool, which offers the required functionalities by means of dedicated user interfaces, i.e., policy administration and process modeler, respectively. It is noted that both policies and data processing workflow models are implemented as ontologies and persisted in an RDF triplet store. We have created the user NISR for this demonstration. We log in GoodFlows. There are three menus: Information Model Editor, Policy Administration and Process Modeler. Both policies and DPWs are defined on the basis of the organization's information model, so we will begin by setting up the NISR information model. A domain-specific information model ontology, modeling data types, purposes, operations, etc. met in the operation of NISR is imported in the system. As we can see, there are three main areas, notably the graph, the list of entities, and the properties areas. The graph area allows graphically editing the different information classes, including the definition of entities and the hierarchies thereof. It is organized in tabs, each used for the illustration of a different graph of the information model. The list area provides a list of the entities, sorted alphabetically, in order to facilitate navigation. The properties area is devised for the management of entities' properties, notably attributes and relations, and applicable rules for the selected entity. The imported ontology is established upon the data privacy vocabulary, while NISR-specific concepts fall under high-level concepts by means of its relations. In the data types graph here, we see multiple entities interconnected with two types of relations. Blue lines denote is a relation, whereas red lines reflect this part of relation. We select the training measurements data type, and the properties area lists the ones characterizing this entity. We see various contains relations, like with calories, peak zones, resting ability, and user ID, as well as a relations, with inferred personal data and with any data type being the most general data type. Likewise, NISR domain-specific entities have been added in the roles graph like the trainer and trainee specializing the entity user. In the purposes graph, purposes like leaderboard specializing requested service provision. And in the operations graph, the operations perform statistical analysis specializing analyze, and publish results specializing make available. The formed hierarchies allow for defining rules upon high-level entities, which will be propagated across the hierarchies, alleviating the need to explicitly define exhaustive rule sets. In that respect, Both positive and negative authorizations will be propagated to more specific entities, while negative authorizations will also be propagated across as part of relations. Thus, a permission defined for the role user will be inherited towards trainee, while a prohibition defined for data type user ID will be propagated to the container training measurements entity, thus implying partial access to the said entity. With the appropriate information model in place, we continue with the creation of the access and usage control rules for the specific organization by entering the Policy Administration menu. This provides functionality for creating, editing, deleting and listing rules, as well as extracting meta rules from explicitly defined ones for high-level entities and rules searching by means of advanced search criteria. We will now create a new rule. As we see, the rule creation form is divided in the 5 areas. The area for defining the rule's general information, that is the rule type, permission, prohibition or obligation, a brief description of the rule and the purpose for which this rule applies. The access and usage action definition area, for defining the elements of the action for which the rule applies. The pre-actions definition area, for defining one or more logically related required actions that must or must not have preceded the enforcement of the rule. The post-actions definition area, for defining one or more logically related required actions that must or must not follow the enforcement of the rule. The contextual constraints definition area, for defining one or more logically related contextual conditions under which the rule applies. We can also see variables that can be used during the rule definition. We will define a permission denoting that, for the purpose of requested service provision, data analysts may publish inferred personal data if the user, that is the data subject, has provided consent for the given purpose and the given operation. Information coming from the information module editor, like purposes, data types, operations, roles and attributes, become available either through pop-up dialogues by pressing the Select from Graph button or by typing in the text boxes with suggestions made by the system through auto-completion. After defining the action for which the rule applies, we proceed with the pre-action concerning consent provision. Logically related constraints are defined for the resource explicitly expressed consent, leveraging the variable's purpose and operation of the main action, while the user is associated with the owner of the main action's resource, that is inferred personal data. We save the rule and land into the home view of Policy Administration. The rule is saved in the underlying or D2.2 store. Specified rules are listed in a table and can be viewed, edited and deleted using the respective row buttons. Next, we will create a prohibition of publishing user ID for the purpose of requested service provision. This rule will act as an exception to the previously defined permission, as it will be propagated across this part of relation between user ID and training measurements. It is noted that the system is deny biased, i.e. something is permitted if at least one associated permission has been defined. Motivated by the need for improved performance during real-time operation, such as the conflict identification and resolution in the context of validating a D2.2 against the access and usage control rules, offline reasoning, that is proactive extraction of knowledge contained in the access and usage control rules, is leveraged. Through the meta rules extraction procedure, most of the required knowledge will be already available by the request time, thus offering performance gains. Once the rule set is finalized, meta rules are extracted by pressing the Extract Meta Rules button through propagation of the explicitly defined rules across the information models graphs. We will search for rules that may apply for the resource training measurements, the operation publish results, the actor data analyst, and the purpose leaderboard. If we open the permission, we see that it was derived from the explicitly defined permission for a more general purpose, resource, and operation, while also the original pre-action is replaced by 2 related pre-actions, depending on whether the user is a trainer or a trainee. However, as we see in the menu search applicable rules, after conflict resolution and merging of rules that may apply for the given intention, that is, an attempted action for a purpose, and under some context, the rule that applies finally is the prohibition, as prohibitions prevail over permissions. Reasoning over the access and usage control rules will feed the procedure of DPW verification and re-engineering towards compliant by design DPWs and efficient negotiation between data consumers and data providers. For this purpose, and fostering explainability, we have developed a functionality for evaluating such standalone intentions against the underlying rule set in order to identify conflicts and to propose alternatives. This functionality is not yet offered via the UI, so we will demonstrate it through Postman. The body of the request denotes the standalone intention that a data analyst intends to publish training measurements for the purpose of projection to the leaderboard. The response contains information made available by the conflict identification and resolution functionality. Specifically, the conflict structure contains the original intention, reference to the rules that lead to the result, and the updated intention, which apart from possibly changed properties of the given intention contains also the combined resources property, grouping together alternative resources to be accessed or used that are contained in the originally requested resource and possible pre- and post-actions. In the case of our example, permissions to publish all that the user ID data types contained in the training measurements data type are found, so the conflict resolution will suggest projection of the requested training measurements in order for user ID to not be included in the published results, along with the execution of the required pre-actions related to consent provision. In this version of the plugin, these standalone intentions are evaluated against the data consumer's rule set, while the intentions themselves are modeled leveraging constructs used in good flows operation, thus serving the validation of a resource consumer DPW step against the internal organizational policies. The next version of the API will include integration with the resource specification plugin. Specifically, the privacy and usage constraints specified by the resource provider in ODL will be translated and imported to a dedicated consumer-side policy model ontology, so as intentions to be evaluated against both rule sets, with the appropriate conflict resolution among rules and rule combination mechanisms in place, and updated intentions to be expressed in ODRL. To this end, the related ODL adapter is currently under construction. Finally, we will demonstrate the creation of a data processing workflow model. For defining upcast data processing workflows, the starting point has been the process modeler offered by GoodFlows. Adaptations and extensions are in the process of being introduced in order to accommodate, on the one hand, the more prevalent data orientation of upcast workflows, and, on the other, the necessary integration to other upcast plugins. We will now create a new workflow model, modeling the NISR process for publishing training measurements on the leaderboard. We land on the main screen of the DPW plugin. The design area at the center allows to graphically model a DPW by defining its tasks and flows. To the left, the environment presents the list of available processing operations defined for the particular organization within its information model as part of the configuration of the tool, sorted alphabetically for facilitating navigation. To the right of the design area, the user is able to define a number of properties for the DPW model, including its association with purposes intended to be served by it, and the identification of the roles that may act as the initiators of the DPW. The user defines purposes and initiators by selecting and deselecting items from the respective lists. We select the leaderboard as the workflow purpose and data processor as the initiator of the workflow, referring in a generic way to NISR in DPV terms. New tasks are created by dragging and dropping operations from the list on the left. We select the operations upon which the demo tasks will be defined, namely perform statistical analysis and publish results. For defining the control and data flows between two tasks, we simply wire the boxes representing the tasks. This way an edge is created, still neutral at this stage as regards their type, that is control or data flow. Edge types can be updated directly by right-clicking on the edge. By clicking on an edge, the user has the option to further define the kind of data the edge shall carry, as well as the flow type or possible conditions that may apply. Again, information coming from the information module editor becomes available either through pop-up dialogues or by typing in the respective text boxes with suggestions made by the system through auto-completion. In this workflow, we set the information entity carried by the edge to be of data type training measurements, which is the output of the operation perform statistical analysis. If required, additional constraints on the properties of selected information entities may be added through expressions and potential logical groups thereof. Further, by clicking on the Add Entity button, additional information entities may be associated with the same edge. Tasks can be seen as the cumulative effect of certain actors performing operations on well-defined assets. By clicking on a task, we can define one or more execution profiles bound to it, grouping together execution parameters, as well as actors and assets described in terms of their types and potential additional constraints. Execution profiles foster flexibility in the definition of workflows through the definition of distinct actor, operation, asset combinations, denoting alternative modes of executing the same task. We proceed with specifying the execution profiles of the two tasks of the workflow. The execution profile for task perform statistical analysis defines as actor any individual holding the role data analyst, while the asset upon which the task will be performed is of type sensor data. More than one actors and assets can be jointly defined in the same execution profile, subject to modeling requirements. For instance, instead of sensor data, the user might set the asset to specifically consist of accelerometer data and electrocardiography data, in order to denote that both subtypes of sensor data, but only them, should be used for the particular task according to the particular profile. Finally, conditions may also need to be added on occasion in order to further restrict the execution of a task as per the execution profile in question. The execution profiles of a task, together with the purposes and initiators defined for the DPW as a whole, can be seen as the overall intention of the DPW designer with respect to implied processing. The execution profile for task publish results defines as actor any individual holding the role data analyst and as asset data of type training measurements. Finally, both tasks and edges can be deleted by right-clicking on them and explicitly proceeding with the deletion. In the case of deleted tasks, all associated edges are also removed from the DPW model. Next, we save the workflow module and the DPW module is saved in the underlying ADF triple. We land in the home view of the process modular, with the table listing the currently available DPW models within the considered organization. The latter can be viewed, edited, and deleted using the respective row buttons. This demo focused on workflow modeling functionalities. Certain aspects of the DPW plugin are still in progress and will be demonstrated in the context of Work Package 3, such as the introduction of new notations into the DPW design tool to support importing third-party datasets and FML operations, and consideration of aspects pertaining to the interoperation with other data plugins, like resource specification and discovery, negotiation and contracting, pricing, environmental impact optimizer, etc. Finally, the information model ontology, the policies and the workflows can be exported along with the associated MX graph representations by pressing Export State in the File menu. Thank you for listening.